to do the questions of the type when the student is asked about the number of one function or number of onto functions, the concept of permutation combination must be clear to you. Given that if the set A contains 5 elements and the set B contains 6 elements, then the number of 1 and onto mapping from A to B is. Actually, there is no difference between mapping and function. The difference comes only when you are dealing with higher dimensional mathematics. So far as board level is concerned, there is no difference between mapping and function. As I told you in the first lecture, that if this is the domain, suppose this is the codomain, and if number of elements in A is more than the number of elements in B, then one function is not possible. And if number of elements in A is less than the number of elements in B, then onto function is not possible. One onto function is possible only when both are containing equal number of elements, in the case if both A and B are finite sets. If both are infinite set, then everything is possible. Means in the case of both A and B as finite sets, one onto mapping is possible only when A and B have equal number of elements. But in this case, A is containing 5 elements, B is containing 6 elements. Hence, in this case, onto function is not possible. For clarity purpose, I just repeat the reason once again, as I told in the previous first lecture. Suppose A, B, C, D, E. These are 5 elements in A. And alpha, beta, gamma, delta, phi and lambda. Suppose these are the 6 elements in B. If 5 arrows are coming out from A, they can't cover all the 6 elements of B. Means at least one element will be there in B where no arrow will reach. Hence, in this case, onto function is not possible. Therefore, the correct answer is C. And this question is of the variety where most of the students feel difficulty. This is of the type where one or onto nature of the function is asked. First, I will check how to find the one nature of the function. You must have studied that to check the one nature of the function, a way you must have studied is start from x1 equal to x2, and finally if we reach at the conclusion x1 equal to x2, note that if this is the only conclusion which we draw from here, then I will say the function is 1. And if we reach at some other conclusion also, that is, suppose I reach at the conclusion x1 equal to plus minus x2, it means x1 is either x2 or x1 is minus x2. That is, we have got two conclusions. In the case if we reach at this type of situation, that is, we reach at two possibilities, x1 is equal to x2 or x1 equal to minus x2. In that case, you will say the function is not 1. It will be 1 only if this is the only possibility we get from here. Note it. Actually, this is correct, but many times it is difficult to simplify this equation and check whether we are reaching at this conclusion or not. to start from here and reaching at this step is many times a lengthy procedure. The way which I am going to tell you has no problem if you are dealing with real numbers. But in the case if x is rational or natural number only or whole number only or integers only, in those cases the way which I am going to tell you, actually that is not correct if you see the solution from subjective point of view. But presently in this exam, because you have to deal with only objective questions, this will be a very helpful concept to use the procedure I'm going to tell you. And if domain of fx contains only finite number of elements, in that case the best way will be use arrow diagram to check about 1 or onto nature of the function. Presently the domain is set of all integers. You must be knowing that z denotes the set of all integers. Afterwards I will tell you the concept about how to check the onto nature of the function. Remember that if y equal to fx is the function and find dy by dx, that is f dash x, if you reach at the result that f dash x is greater than equal to 0 for every value of x, you will say the function is 1. Or if f dash x is less than equal to 0 for all values of x, in that case also you will say the function is 1. But if f dash x can be positive also and negative also, in that case fx will not be 1. Remember this result, it will help you a lot in checking the 1 nature of the function. And to check the onto nature of the function, we always find range of the function. If range is equal to codomain, the function is said to be onto. If range is a proper subset of codomain, in that case you will say the function is not onto, that is in that case the function will be called into function. And how to find the range of the function? From the given equation, find the value of x in terms of y, and once you have got the value of x in terms of y, check for what values of y that function is defined. Set of those values will be called range of the function, but this is correct only if x is allowed to take all types of values: natural number, whole number, integer, rational number, irrational number, that is any real value. And in the case if x is allowed to be taking natural values only or whole number values only or integral values only, in those cases best will be use arrow diagram to check the onto nature of the function. As I told you just now that the questions of the type when domain is not a finite set, in that case to check the 1 nature of the function, we always find f dash x. Again I tell you that this method is not correct from subjective point of view, but from objective point of view this is correct because the result will be always correct. For the first question, fx is x cube, therefore f dash x will be 3x square. And as I told you, if derivative is surely greater than equal to 0 or surely less than equal to 0, in those questions function will be called 1. And here it is clear that derivative is greater than equal to 0, therefore the function will be 1. In the second question, f dash x is 1, which is again surely positive. Therefore this is also 1 1, this is also 1 1. And in the third case, f dash x is 2, again this is positive, and derivative greater than equal to 0 means function is 1 1. Had it be minus 2x plus 1, in those questions I would say f dash x is minus 2, and because derivative is surely negative, therefore the function is again 1 1 if it is minus here. But suppose the case when fx is x power 4 plus 1, then in that case f dash x will be 4x cube, and 4x cube can be positive also and negative also. For positive values of x, the answer will be positive. For negative values of x, the answer will be negative. Hence f dash x can be positive also or negative also. Hence in this case the function will not be 1 1. Therefore this function will not be a 1 1 function. Similarly here also f dash x in this case will be 2x. Again 2x can be positive also and negative also. Hence you will say the function is not 1 1. And once we have seen that this is not 1 1, therefore it cannot be 1 1 on 2 also, because for 1 1 on 2 it should be 1 1 also and on 2 also. If x is not allowed to take every type of values, in those questions find the range by putting the values of x one by one from domain, or use arrow diagram to check about the onto nature of the function, whichever you find easier. Here domain is 0 1 2 3 minus 1 minus 2 minus 3 and so on. Again codomain is also and so on. Let us discuss about the case A. For onto nature, I told you that for the function to be onto, on every element of codomain, one or more than one arrow should reach. If there is even one element in codomain on which no arrow reaches, then the function will be not onto. On every element of codomain, one or more than one arrow should reach for the function to be onto. See, when I put x equal 0, I will get the answer 0. Therefore 0 will go to 0. If I put x equal to 1, I will get the answer 1. If I put x equal to 2, the answer will be 8. For 3 you will get 27 and so on. You can see very easily on 2, 3, 4, 5, on these elements no any arrow is reaching. Hence the function is not onto, and because it is 1 1 but not onto, therefore you will say A is again wrong choice. And now for this function, again drawing the arrow diagram 0 1 2 3 and so on and so on, and here also 0 1 2 3 and so on, minus 1 minus 2 minus 3 and so on. You can see easily that when x is 0, the value of fx is 2. When x is 1, the value of fx is 3. When x is 2, value of fx is 4. When x is -1, the value of y is, that is fx is 1. For -2, the answer is 0. That is, you can see very easily on every element of codomain, exactly one arrow is reaching. If on every element of codomain exactly one arrow reaches, the function is both 1, 1 and onto. Hence, B becomes the correct choice. But still, for more clarity, I will discuss the case C also. Clearly, for x equal to 0, the value of y is 1. For x equal to 1, the value of y is 3. For x equal to, the value of y is 5. You can see very easily on 2, 4, 6, etc. no arrow is reaching. Hence the function is not onto, because for the function to be onto, on every element of codomain, one or more than one arrow should reach. If there is even a one element in codomain on which no arrow reaches, then the function is not onto. Hence I can say B is the only correct choice. Agreed that after getting the correct choice as B, I need not proceed to the choice C, but for clarity purpose I have discussed the choice C also. And as I told you previously also, to check about one function, we always find derivative. If derivative can be positive also and negative also, then the function is not 1. But if the derivative is surely greater than equal to 0 or surely less than equal to 0, in those questions the function will be called 1. What is 1 function? I think you must be knowing about it. When I am doing the final revision, I am expecting that the basic theory is all clear to you. Here in this question again, fx is given to you as x power 4. Therefore, f dash x is 4x cube. Clearly, the value of 4x cube can be positive also and negative also, depending upon the values of x. For positive value of x, answer will be positive. For negative values of x, the answer will be negative. Hence, f dash x can be positive also and negative also. Hence, the function is not 1. And next is to check about the onto nature of the function. And as I told you, to check about the onto nature of the function, find the value of x in terms of y. Here y means fx. Find the value of x in terms of y and see for what values of y that function is defined. The set of values for which that function will be defined, that set of values will be called range of the function. And if range is equal to codomain, the function is onto. Here x power 4 equal to y means x equal to y to the power 1/4, because here even number is there. Therefore, this will be defined only if y is greater than equal to 0. And the values for which this function is defined, set of those values becomes the range of original function. Hence, the range of this becomes 0 to infinity. But codomain is set of all real numbers, because range is proper subset of codomain. Hence, the function is not onto. Hence, it is neither 1 nor onto. Actually, by chance, I have missed the fourth choice, and fourth choice must have been neither 1 nor onto. Actually, I have discussed many questions on 1 on 2 nature of the function because I know that this type of questions are taken to be difficult by most of the students. And in this question again it is given that f takes r to r be defined as fx equal to 3x. Choose the correct answer. That is, we have to check the 1 on 2 nature of the function. It is clear that fx is 3x, and as I told you that for checking the 1 nature of the function, the best is find the derivative. If derivative is always greater than equal to 0 or always less than equal to 0, then the function is called 1. Here f dash x is 3, and because derivative is always greater than equal to 0, always greater than equal to 0 means for any value of x it is positive. Because x is not present, it means for every value of x the answer is 3, and 3 is a positive number. Hence, because for every value of x derivative is positive, hence the function is 1. And now to check the onto nature of the function, first of all I write y for fx. That is, I get y equal to 3x, that is x equal to y by 3. And now see for what values of y this is defined. Whatever is domain of this function, that will become range of this function. And because it is always defined for every value of y, hence the range of this function is R. And because range and codomain are equal, therefore the function is onto also. Hence the function is both 1 and onto. That is, A becomes the correct choice. In this question, it is told to us that let set A contains the element 1, 2, 3. Set R is defined by this and it is a relation in A. Then find the minimum number of ordered pairs may be added so that R becomes an equivalence relation. As you know that for the relation to be equivalence, it should be reflexive, symmetric and transitive all. And because R is a relation on A and A contains 1, 2, 3, therefore for R to become reflexive, 1, 1, 2, 2 and 3, 3 must be present in R. All the three must be present in R. Then only the relation will be called reflexive relation. And now we have to check about the symmetric nature of the relation. As it is clear that 1, 2 is present in R, hence for the relation to be symmetric, 2, 1 must be there in R, 2, 3 is there in R, 3, 2 must be there in R, and once these two ordered pairs are added in R, the relation will become reflexive also and symmetric also. But because I want the relation to be equivalence relation, hence it should be transitive also. And now we will check that after adding all these 5 elements in R, whether it has become a transitive or not. And hence this new R is this, and 1, 2 and 2, 3. It is clear that this is reflexive also and symmetric also. And to check about the transitive nature of this, it is clear that 1, 2 is there, 2, 3 is there. then according to the condition of transitive relation, 1 3 must be there in R. Now I will have to add 1 3, and because 1 3 is there, for the relation to remain symmetric, 3 1 will have to be added, and once I add 3 1 also, this is complete A cross A. Note that A cross A will be containing 9 elements because A is having 3 elements, and these are clearly 9 ordered pairs. That is, R has become now A cross A, and A cross A itself is always an equivalence relation. Hence, I can say after adding this, 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 and this, the relation has become equivalence relation. These two are already there in R. Hence, the number of elements to be added has become 7. Hence, the number of ordered pairs to be added to this R must be 7, because 1, 2, 3, 4, 5, 6, 7. And because this is the lecture of final revision, therefore I am dealing with only those questions which are usually taken to be difficult by the students. Agreed, this whole chapter is taken to be difficult by most of the students, but the questions which I am dealing, they are really difficult for most of the students. In this question, it is told to us that let the set A is containing elements 1, 2, 3. Then find the number of relations containing 1, 2 and 1, 3 which are reflexive and symmetric but not transitive. It is clear that the set A is having elements 1, 2 and 3. Therefore, A cross A will be 1 1, 1 2, 1 3, 2 1, 2 2, 2 3, 3 1, 3 2 and 3 3. Clearly there will be 9 elements in A cross A. You can count, these are 9, 3 into 3. Agreed that because the number of subsets of this set is 2 to the power 9, hence 2 to the power 9 relations are possible on the set A. But we have to find those relations which are reflexive, which are symmetric but are not transitive. We will find such relations. First thing, because it should be reflexive, hence in R 1 1, 2 2, 3 3 must be there. And about 1 2 and 1 3, he has already told us that they should be there. Hence, I have included 1 2 and 1 3 also. And now we have to discuss about the remaining ordered pairs. And once we have added these three, the relation has become reflexive. And because I want the relation to be symmetric also, once I have included 1 2, 2 1 will have to be included. Once I have included 1 3, 3 1 will have to be included. And after we have included these two, only you have to decide about 2 3 and 3 2. Now 4 possibilities arise. One possibility, I don't include any of them. Second possibility is I include this and don't include this. Third possibility is I include this and don't include this. And fourth possibility is I include both of them. I will be discussing each possibility one by one. Suppose I don't include anyone and I complete here only. Now this relation is reflexive and symmetric both. We have to check about the transitive property of this relation. And you know that condition of transitive relation is whenever AB and BC belong to R, then AC must surely belong to R for every two ordered pairs in which these two elements are same. And one thing more is to be taken care of is you must have noted it while doing practice also, but just for more clarity I am telling you, while checking the condition of transitive relation, you should not waste time in using those ordered pairs in those cases in which one ordered pair is of the form AA, because if I use such type of ordered pair, dissatisfaction will be never there, and I want to check is there two ordered pairs on which the condition of transitive relation is not satisfied. Suppose I take one ordered pair as AA, second possible ordered pair as AB. Suppose these two are belonging to R. The result of combining them will be AB, and AB is already there in R. Therefore, if I use one of the ordered pair in which both are same, in this type of situation, dissatisfaction will never arise. Hence, no need to check those cases in which one ordered pair has both the elements same. Hence, for checking the condition of transitive relation, these three elements I will not use. I will be using these elements one by one. Suppose one order pair I choose is 1, 2. If I have chosen first order pair as 1, 2, for using the condition of transitive relation, the second possible order pair which I can choose is only 2, 1, because 1, 2 cannot combine with 1, 3, 1, 2 cannot combine with 3, 1. And the result of combining them will be 1, 1, which is there in R. Therefore, the condition of transitive relation is satisfied so far. Now take the second case when 1, 3 is taken as first ordered pair. Second ordered pair cannot be taken as 1, 2. Second ordered pair cannot be taken as 2, 1. Second ordered pair is possible to take 3, 1. And the result of combining them will be 1, 1, which is there in R. Hence again the problem has not arisen. And the other possible case is when I use the first ordered pair as 1, 3, then I will have to use the second ordered pair as 3, 1. The result of combining them is 1, 1, which is there in R. Therefore, the problem of transitive relation has not arisen in this case. Now the next case is if I use 2, 1 as the first ordered pair. Now the second ordered pair possible is 1, 2 also and 1, 3 also. If I combine 2, 1 with 1, 2, the result will be 2, 2, which is there in R. No problem. Condition of transitive relation is satisfied so far. If I combine 2, 1 with 1, 3, the result will be 2, 3, which is not there in R, because in this case the condition of transitive relation has not satisfied. Therefore, you will say the R is not a transitive relation. Hence, this is one possible answer. And second possible answer is if I have included 2, 3, and if I include only 2, 3, then the relation will not remain symmetric, because I want the relation to be symmetric. Therefore, I will have to include 3, 2 also. And if I include both of them, then it is equal to A cross A. You can see very easily. And if it is equal to A cross A and A cross A itself is always reflexive, symmetric, transitive, all the three, therefore now R will become a reflexive, symmetric and transitive, all the three. Therefore only one possible relation is there, which is reflexive, symmetric but not transitive. In this question it is given to us that let set A is equal to this, set B equal to this, and let F be equal to this. Be a function from A to B. For the function F to be 1 1 and onto, the value of P is equal to, you have to find the correct choice. As it will be more easier to understand with the help of arrow diagram, therefore I am drawing the arrow diagram first. 1 2 3 A B A B and C. You know that for the function to be both 1 1 and onto, on every element of B exactly one arrow should reach. And in this question it is given that 1A is in F, therefore the arrow of 1 will go to A. 2B is there in F, therefore arrow of 2 will be B. And the only possible place where the arrow of 3 can go is C only, because on every element of codomain exactly one arrow should reach. Hence PC means the value of P must be 3. Therefore C is the correct choice. In this question it is given to us that for real x let fx is equal to this, then you have to find the correct choice. That is, we have to check about 1 1 and onto nature of the function. As I have already told you in the previous questions, for the function to be 1 1, the best possible way is find the derivative. If derivative f dash x is always greater than equal to 0 or always less than equal to 0, then the function will be called 1 1. And if f dash x can be positive also and negative also, in those questions fx will not be 1 1. And this way I am going to use in this question. Many students use the way that start from fx1 equal to fx2 and they say if x1 equal to x2 is the only conclusion from here, in that case the function will be 1 1. This is correct, but this is many times makes the solution lengthy or difficult or sometimes impossible also. And using the same concept here also, as fx is given as x cube plus 5x plus 1, f dash x will be 3x square plus 5, which is clearly greater than 0 for all values of x. Hence the function will be 1 1. The reason being, you must be knowing that if the derivative is greater than equal to 0, the function is increasing, and increasing function is always 1 1 function. Or if derivative is surely negative, then the function is always decreasing, and always decreasing means the function is 1 1. If you know the meaning of the word 1 1 function, you must be knowing that if the function becomes always increasing or always decreasing, the function will become 1 1. And for checking onto function, I will say the best possible way is, remember that if fx is equal to any odd degree polynomial, whether 1 degree or 3 degree or 5 degree, fx will be a onto function. It is true for every odd degree polynomial, and for even degree polynomial they are neither 1 nor onto. They are never 1 they are never onto in the case of even degree polynomial. But for odd degree polynomial, onto will be surely there. But about 1 it may be 1 it may not be 1 For even degree polynomial, that is neither 1 nor onto in any case. Again, it is simplest to do this question with the help of arrow diagram. In this question, it is given that the set A has 3 elements, the set B has 4 elements. The number of injections that can be defined from A to B is, suppose this is the set A, suppose this is the set B, A, B, and it has 3 elements, say A, B and C, and B has 4 elements, say those are alpha, beta, gamma and delta. You have to find the number of injections that can be defined from A to B. For your clarity, I am finding the number of functions also. Agreed, it is not required here, but just for more clarity, I am telling you how to find the number of functions. It is clear that for any arrow diagram to represent a function, from every element of domain, one and only one arrow should come out. There is no any restriction on reaching the arrow. For the arrow diagram to represent a function, the only condition is from every element of domain, one and only one arrow should come out always. And there is no any condition on reaching where the arrow will reach. That is not any problem. Therefore, to find the number of 1 function, the arrow which will start from here, that can go to any of the 4 places. That is, for the first arrow there are 4 ways to go. The arrow which will start from B, that can go again to any of the 4 places, 4 ways. The arrow which will start from C, that can go again to any of the 4 places into 4, that is 4 cube. That is 64 functions are possible when A has 3 elements and B has 4 elements. But here he is asking the number of injection. He is not asking about the number of functions. He is asking the number of 1 function, because injection means 1 function. For the function to be 1, the condition is on every element of codomain, 1 or less than 1 arrow should reach. Less than 1 means no arrow. If on every element of codomain 1 or less than 1 arrow reaches, that is 1 arrow or no arrow reaches on every element, then the function will be called 1, and the function will be onto if on every element of codomain 1 or more than 1 arrow reaches. Take care, I am saying that on every element. This is to be noted, and in this case I am discussing about the number of 1 function. The arrow which will come out from A, that can go to any of the 4 places. Hence there are 4 ways for the arrow of A to go, therefore 4. And the arrow of B has only 3 remaining possible places to go, because wherever the arrow of A has gone, the arrow of B cannot go there. Suppose the arrow of A goes to beta, then the arrow of B cannot go to beta, because in that case beta will be having 2 arrows to reach. and the condition of 1 function is on every element of codomain, one or less than one arrow should reach. Hence, the arrow of B has only 3 possible places to go, therefore 3. The arrow of C has only 2 possible places to go, therefore that is 24 functions are possible which are 1. Hence C is the correct choice. And in this question again he is asking the nature of function. He is asking which one of the following is a bijective function on the set of real numbers. On the set of real numbers means domain is the set of real numbers. The first possible function is 2x minus 5. As I told you in previous questions that any function represented by even degree polynomial is never 1, never onto. But any function represented by odd degree polynomial is surely onto, but about 1 you will check with the help of derivative. As I told you, if derivative is always greater than equal to 0 or always less than equal to 0, the function will be 1. And if derivative is sometimes positive, sometimes negative, then it is not 1. Here first case is y equal to 2x minus 5. Clear that dy by dx is 2, which is greater than 0 for every value of x. Hence the function is always increasing, and always increasing means the function is 1. And onto is always there whenever the function is representing odd degree polynomial. Hence this function is both 1 and onto. Once we have got the correct choice, it is not required to proceed further. Still, for your clarity, I am discussing the other cases also. As I told you that function represented by even degree polynomials are neither 1 nor onto. Hence C and D automatically becomes wrong choices. That is, they are neither 1 nor onto. About B, remember that every even function is never 1 because the graph of even function is always symmetrical about y-axis. Note that now I am saying about even function. About these two I was saying about even degree polynomial. Even degree polynomial and even function are two different things. If you know about the meaning of the word even function, you can see very easily it is even degree polynomial also and even function also, because for the function to be even function, f minus x should be equal to fx. For example, fx is equal to cos x is not even degree polynomial, but it is even function because cos of minus x is cos x. If I take fx is equal to x power 4 minus x plus 3, it is even degree polynomial, but it is not even function because f minus x is equal to x power 4 plus x plus 3. Note that I am always supposing that you have studied all these things in 12th class. This is only a revision class. In revision class, I just revise the concept or I discuss those concepts where usually students feel difficulty. And because for even function, the graph is always symmetrical about y-axis, and if the graph is symmetrical about y-axis, then it cannot be 1. Again, presently I am supposing that the meaning of the word 1 function is clear to you, and because it is even function, because mod of minus x is mod of x, hence this is even function, and even function means It cannot be 1 1. Hence the only correct choice is A.